everyone, and welcome to another Spring Break Online event. I cannot believe I'm super excited to bring this one to everybody today, because today is Stump a Scientist. That's right. We are asking for your toughest science questions. And so you can put those questions into the chat. We will get them. So if you have your questions ready, go ahead and type them out, and we'll see which ones we can pick out as our toughest science questions. But to start off, of course, my name is Amy. I'm a scientist here at Science North, and I'm very excited. I'm actually broadcasting, of course, from my home, because we are at home this spring break. But home is a really, really important place, and especially where our home is and what land that it is situated on. And so we at Science North, we always want to acknowledge the place that we are. And at Science North and in Sudbury, we are on the traditional and ancestral lands of the Atikameksheng Anishinaabe and also the Wanapitei First Nation. And it's a really special place here in Sudbury, because not only do we have a wide variety of different cultures and people, but the land is a really important base for us. We want to also acknowledge other people that live here, including the Métis Nation, for their cultural and economic contributions to our area. And the land that we sit on belongs to something called the Robinson-Huron Treaty Area. And as people who live on this land, we are all treaty people, and it's really important for us to all be thinking about what treaty area we live in, and to be an active part of that. So maybe you're coming to us from Sudbury, maybe you're coming from us from a different place in Ontario or across Canada or around the world, but take a moment to just really appreciate the land that you are on, and what traditional territory or treaty area are you currently located in. So I just want to thank you a lot for joining us online today. You know, we sure do miss you all at Science North. And I know many of our scientists were quite sad when we weren't able to open the Science Center, because that's our favorite place to be. We love doing science with you. We love engaging with you. And we just can't wait for you to come back and welcome you back through our doors of Science North and Dynamic Earth sometime in the future. And so we know that we have to do science during spring break, though. And so while we're providing this amazing programming all week, and if this is your first time with us, then that's great. But just know the rest of the week as well, we have amazing programs going on. They're free. But of course, Science North is a charitable and nonprofit organization, and we really would appreciate any donation that you could offer us, just so that we can continue to provide you these great science experiences, not only this week, but for many years to come. And you can donate right through your Eventbrite registration, or for any workshop that you decide to register to, or you can click on the donate link at sciencenorth.ca at our website. So here we go. We're going to get started. And I have to introduce you to something that's incredibly important, because this whole event would not be possible without the stump. Now, this stump is really, really important, okay? The stump is the thing that you want to have as viewers today. You want this stump, because if you are capable of stumping one of our scientists in our prototype and tech lab area, we've got some really cool tools that we can use, right? And one of those tools is a wood burner, and your name will be wood burned on our stump, and this stump will then sit in our Think Lab at Science North. And if you ever come back, then you can see your name on the stump and prove that you were able to stump a scientist. Now, there's a couple of rules to this event. Of course, the first rule is that the question must have an answer to it. So there's many, many different things in science that, we just don't know the answer to yet. And, so the answers from our scientists could be, we just don't know, because really there isn't really a known answer. That's okay. But in order to stump us, it has to be something that does have an answer. So that's a really, really important part. Rules for my scientists, I'll get to in a second as I bring them online. So let me introduce to you the scientists that I have today. I'll start off by, I think some of my favorite people, because I'm a biologist. So I'm going to introduce you, starting off with our biologists to come on. So I'll bring on Megan Mitchell first. Megan Mitchell is a zoologist, so you can ask her questions all about animals. We'll bring on Bruce Doran next. Bruce is looking a little frightened. There we go, Bruce. Bruce is a human biologist. He's also a biologist, and I'll tell you, he loves mosquitoes more than any other animal in the world. But you can also ask him some great questions about human biology. And then speaking of human biology, we'll bring on Nina. Nina can come on. Nina is an expert in human biology and all the things that are a little bit techie in our world. And the next one I'll bring on is Katrina. Katrina knows how. Where did Katrina go? She's coming on here in a second, or did she disappear on me? She disappeared on me. Well, okay, we'll bring Katrina on in a second. Well, speaking of tech, because Nina's very good at tech, I'll bring Tyler on next. So Tyler is kind of a tech wizard. There he is. He's also knows a lot about physics and space sciences. So there is lots going on there. Then if we go a little bit more into physics, we have Melissa Rady. She'll come on. There she is. Excellent. Welcome, Melissa. Great to have you. You can ask her questions about physics, chemistry, all kinds of different stuff. You might find Melissa in the Discovery Theater at Science North if you're coming through. And then we have, going back, we have Katrina Pisani. Katrina, I said, knows everything about your brain. So it's all about how does your brain work, the psychology of your brain. That's a very cool and interesting science. And of course, last but not least, coming to us from Dynamic Earth, because that's a very important place, we have Jennifer Beaudry. Jennifer knows everything there is to know about mining, geology, rocks, all of that kind of stuff. And that is our team for today. So welcome them, and we already have questions flowing in. So here's the rules for the scientists. Are you ready, scientists? I don't want to see anybody looking at their phones and Googling things or at their computers or anything like that. It's all got to come up from right up here. So that's your rules for today. I've given our audience their rules. Our questions must have an answer. That is very, very important for sure. And if the answer is we don't know because science doesn't know, that's okay. That is definitely the answer there. All right, so here we go. I'm going back up into our questions. There are so many different. Oh, here's a great one coming in from Kimberly. How are rainbows made? Who can answer that out of our panel? How are rainbows made?
Do you want it, Melissa, or do you want me to take it?
I was like, no, this one's for Tyler.
Tyler. All right, Tyler, tell us, how are rainbows made?
Okay, so after the rain, there's not just clear skies, right? There's tons of teeny tiny little droplets of water, still like little raindrops, but not heavy enough to fall. They're being blown around by the wind up there. And those droplets, each and every one of them, will act like a prism. It'll catch the light. It'll actually bounce the light. And this is maybe harder to explain without like drawing it. But imagine you've got a ball of water and the light comes in and it bends around and it actually like bounces through it. But each color bounces at a slightly different angle. So you get your red, green, blue, your Roy G. Biv, all bouncing at slightly different angles to separate them out into the colors of the rainbow. And because I'm saying bouncing inside the raindrop, and that's why you've always got to look for your rainbow on the other side of the sky from the sun. You don't want to look like towards the sun to get your rainbow. You want to look away from it because it's actually scattering it back towards you, which is really cool, right?
That's pretty awesome. Kimberly, I don't think you stumped our scientist on this one. Tyler seems like he's quite authoritative on how light works. And Bruce, what do you got?
Actually, Kimberly, if you want to make your own rainbow, just take a hose with a nice nozzle and just have it like misting up. My daughter does that all the time, and you'll actually see a rainbow. So you can make your own rainbow at home.
Very cool. Does it need to be sunny out, Bruce?
Yeah, it needs to be sunny.
Okay. That's a good one. That's a really great summer thing to look forward to in the summer. That was really, really good. All right. That is a great question. Thanks, Kimberly. That's fantastic. All right. We've got another question coming in from Lindsay. How many animal types are there in the world?
I'm assuming that's to me.
Yeah, well, yeah, Megan, you're a zoologist. I'm kind of looking to you. What do you think?
Okay.
How many animal types are there in the world?
if I remember my numbers correctly from university a very long time ago, there are approximately 8.5 million species of animal on our planet. And that number fluctuates. It changes because some animals go extinct at rates that we don't yet understand, but also new animals are discovered all the time too. So if I remember correctly, it's right around 8.5 million species of animal on our planet.
And that includes all kinds of things, right? Like that includes fish and insects and arachnids and mammals and you name it, right? It includes the whole gamut.
Yeah, exactly.
Wow, that was a great question, Lindsay. I'm surprised you came up with that number, Megan. Somebody Google that, make sure she's correct. But I think that's pretty good. Yeah, Bruce is gonna get on that, I think. No,
I didn't want to be the first one stumped.
I think all of our scientists don't want to be the first one stumped. That's kind of what they're going to. Oh, this is a good one. From Naomi. So Naomi is asking, where does wind come from? Now, I think everybody is kind of, I don't know, Tyler, do you have an answer for that?
Yeah.
I was like, I'm not really allowed to play because I'm the host and I'm kind of the weather specialist around here. So I was kind of like, I don't know.
You can take it if you want, Amy. Go ahead. Why not?
You're still a scientist.
You're just as much a scientist as the rest of us.
Go ahead, Tyler. Go ahead.
Okay.
I'll add to it.
So I'm not the weather expert, but there are these things in the atmosphere. Atmosphere is all the air around us, and called high pressure and low pressure zones. So sometimes we've got areas where there's a little bit denser air. It's weighing down a little bit more in some parts of the world, and it's a little bit less in other parts. And basically, it doesn't want to do that. That doesn't make any sense. It wants to flow from low pressure to high pressure. And so it's going to do that. And that's the wind going whoosh out from the high over to the low. And a lot of that has to do with heat, where it's warmer, where it's colder, and also other weather patterns, where there's more water in the air can affect it. Oceans, mountains, it gets really complicated what causes these high and low pressure zones to form and move around. But basically, when you have wind, it's because you've got high pressure near low pressure, and that high pressure air is whooshing over to join up into the low pressure area.
Yeah, absolutely. And everything, a lot of different things can affect that. It can, and including how much water is in the air as well. So if there's a lot of water sitting in the air, that you can actually have a lower air pressure because of water. So you'll often hear on our weather forecast or something like that, like a weather forecast will say, well, we have an area of low pressure coming into Sudbury today, and we get lots of rain, right? And an area of high pressure, we get beautiful, beautiful sunny skies. And if you notice, when you have storms or things that go through, wind will come often before a storm or right after a storm because of that moving, changing air pressure from one place to another. So absolutely, that was, you can't, I don't think you were able to stump us on wind today. What do you think, Tyler? I think we did pretty well, right?
I think we got that one.
All right, no, that's really, really good. That's really good. Oh, this is a good one. This is a really good one. What would happen to our planet? And I think almost everybody could weigh in on this. If the sun went away for a day. Annie sent us this one. What would happen to our planet? This is a great question. If the sun went out for one day.
If it went out or if it went away?
It says it went out. Sorry. What if the sun went out for one day? Just went boom.
Just for one day, or just one day it goes out and then it never comes back?
It says for a day. I'm going to go with one day.
It's off. Somebody pulls the light switch. It's off. And then it comes, and then a day later, and it comes back.
Wow. The teenagers would never know when to wake up.
Oh, Bruce, always the joker.
All the bad jokes.
all the time. I love it.
Well, it'd get cold, wouldn't it?
It would get.
I think we'd die.
Yeah.
Without the sun for one day, that's it.
That's it?
I think.
Yeah.
Well,
It would
we've got
get.
a lot of greenhouse gases, so maybe we'll just have enough heat for some of us to survive.
Well, I don't think. Maybe if you're like next to a volcano on Iceland or Hawaii or something, but it would get very, very cold because all of our heat, after all, does come from the sun. On the other hand, a lot of our heat comes from not the sun when we are on the night side of the planet. Remember that whole half of the Earth that doesn't get sunlight?
Yeah.
Well, it's radiating heat out into space, and it's not like it's getting a huge amount of warmth coming from the other side of the planet to warm it up. It's just like chilling, getting cooler over the course of the night, and then the sun rises and it warms up again. So we would see a drastic drop in global temperatures, but I don't think we'd see like, carbon dioxide snow or anything. It would just be like, hey, it's all of a sudden winter and it was July because the sun went out that day, something like that. We'd have to do a little bit of math to figure out exactly how cold it would get, but it would not be the end of the world. I'm pretty sure it would just be really, really, really weird. I mean, the sun going out would also be really, really weird because the sun's enormous, and just make that stop is kind of crazy. But maybe, is that a stumpy question? I don't know.
I don't know. How much heat does the sun actually radiate at night, though? Like, if it were out for 24 hours, there is no radiating heat whatsoever coming from the sun.
Yeah, it's only radiating onto the side that it's hitting, though. So you think about the night side of the sun isn't really being, or the night side of the Earth isn't really being affected by the sun. So we just have two night sides. So it's like we have 24 hours of night as opposed to 12 hours of night followed by 12 hours of day, which is, yeah, that's going to affect the heat balance of the planet. It's going to be twice as cold at the end. Like, think of how much temperature drops over the course of the night. This time of year, you can go from a daily high of like 20 here in Sudbury on the hottest day last week, right? And then in the middle of the night, we woke up in the morning and it was like 7 degrees. Okay, well, we double that heat drop, and then it went from, instead of 20 to 7, it goes down to like, minus 13. Well, the world does not end if the sun comes back on.
There are parts of the world too that don't get sunlight for months at a time as well, that don't get a lot of sunlight. But I definitely think plants and animals would be confused for 24 hours.
Their patterns would be all messed up, right?
Yeah, nocturnal animals would rule the world for 24 hours.
Bats would be really tired.
Yeah.
I think one thing we got to keep in mind is that 3/4 of our planet is covered with water. Water can accumulate a lot of heat and keep that heat and then radiate that heat. So within 24 hours, yes, the planet might cool off, but I don't think it would turn into a big snowball in 24 hours. Now, some animals and plants might have a harder time. So ones in the tropical areas, they might have a harder time than, let's say, the ones in the northern hemispheres where it's just like, it's cold today. I got fur, or I got adaptations to deal with the cold, even if it's just for one day. So I think I'm with Tyler. Life is not going to cease or anything like that. It might get cold for one day. The one thing, you wouldn't be able to see the moon. You wouldn't be able to see the moon. And then the other thing would be cool is that during the daytime, when you're looking up, you can't see the stars. You would be able to see the stars. So you would be able to see constellations that you wouldn't be able to see normally. So that would be kind of cool.
That would be cool. That
Very
definitely would be cool. I don't know. I'd love to hear in the comments, do you think we were able, this is kind of one of those tie things, and I'm not quite sure. So I'd love to hear, put in your comments, do you think, I can't even remember who asked this question now, and I can't find it. It's like we got so many questions coming in. Renata might have to go back for us and see who asked that. But do you think this person was able to stump the scientist, put a stumped if you think so, and not stumped if you don't think so? We'd love to hear in the comments. Stump! Oh, we got coming in. We stumped them. That's one of the. That does. Oh, you guys got stumped. That's coming into the comments. Oh no! Oh no! Oh, that is. Oh no! so that's good. We'll keep thinking. No, stop. Oh, we're up for the scientists on this one. This is good. This is good. Are we stumped? Are we not stumped? Nope. Okay, I think it's coming in. We're okay, guys. We weren't stumped on this one. I'll put the Stump Trophy over here for just a second. All right, I saw a question a way long time ago from Shreya and Elena, who asked, and this, Jennifer, is definitely for you, how many different types of rocks are there in the world?
That is a definitely good question. There are 3 main families when it comes to your rocks. So you've got your igneous rocks, your metamorphic rocks, and your sedimentary rocks. And then depending on how they're made, so the different minerals that you find within the rocks, there's going to be subgroups within there. So here in Sudbury, we can actually find all 3 types of rock: igneous, sedimentary, and metamorphic. Metamorphic meaning that it changed. So you started off with one type of rock, and it, with heat and pressure, morphed into something different. We have a lot of that here in Sudbury. We had a meteorite impact 1.85 billion years ago that really altered the rock that we have here in Sudbury. But we don't need to look too far. If we go to Manitoulin Island, you have beautiful, beautiful sedimentary rocks that are filled with fossils, and some great fossil hunting out that way as well. And then if you look at the igneous rocks, well, the igneous rocks, we still have those in Sudbury. And a lot of people might actually have those in their kitchen. So if you have a granite countertop, granite is an igneous rock and often used for countertops. But be careful, because a lot of those countertops where you think they are granite could be very well be other rock types. Aha. So there are the 3 main rocks, but every group has a different subset of different rocks based on what type of minerals we find within.
And it sounds to me, Jennifer, as it's almost kind of infinite in a way.
It can
be so many different combinations.
There can be a lot of different combinations, absolutely. And we're finding new minerals. So just like you find new species in animals, there are geologists that specifically look for different types of minerals. And understanding how those minerals were crystallized, so were formed into these types of minerals and eventually into these types of rocks. So when we look at geology, it's really interesting because you can go from a microscopic scale. So when you're starting to look at the minerals themselves, so think about a cake. A cake you need to bake, you have ingredients that go into your cake. So minerals are your ingredients to making your cake, which is the equivalent of a rock. So all of these new ingredients that we discover make up different types of rocks or families of rocks, and we put them all together, and you can really start taking that step back and then understanding the Earth's history. What I love about geology, it is a history book. You just need to learn its language, and it unlocks so many mysteries and stories.
That's awesome. That's awesome. Thanks, Jen. I was like, I don't think anybody else could have answered that. So thanks. We're so glad that you came today, because we would have definitely been stumped on that one for sure. All right, now this is a tricky one. This is coming in from what I think might be a car service facility. So I know they're joining us from Brockville. They would love us to explain the physics of a drive shaft. Now,
That's Tyler.
I'm a marine biologist, so I got nothing.
I'm looking at Melissa or Tyler on this one.
I remember your feud with mechanics, Melissa, over the oil. I think you should take it.
No, I don't know what a drive shaft is, so I can't explain the physics behind it.
So what you're saying is we all drive cars but know nothing about them. Is that what we're all saying?
Okay, so
Tyler's got something though.
a drive shaft is literally what it sounds like. It is a shaft that drives something. Okay, so you've got an engine on one end, right? That's on the screen. All right, this fist is the engine. This finger is the drive shaft coming off the engine, and the engine spins. It spins the little stick coming off the engine, and then that goes back to an axle, which will then take a gear called a differential, which will turn your rear wheels. So literally, it's transmitting torque through just its own rotation. Now, there's a little bit more physics than that, because a solid drive shaft is actually a pretty bad idea for a rear-wheel drive vehicle, because you've got your car is got flexing slightly in the frame. You're presumably you've got suspension, so you're going up and down with your axle, and so you're going to have that shaft want to move and bend, which means it's going to snap off the engine. It's going to flap around as it's turning, and then tear you apart. So what you end up with inside instead is something called a universal joint, which is a form of knuckle, which can actually turn and transmit that torque. That torque is that twisting force while actually bending. And it really just looks like a couple of knuckles. You can imagine, like I've got my knuckles locked together here. It's hard to see. But if I turn one, it's going to force the other to turn, but they can actually slide a little bit. If you've got a couple of those together, you've got your U-joint, which can transmit that spinning force through the drive shaft while still allowing it to bend. I don't know if that's the answer that they were looking for in Brockville. They know more about it than me, probably.
I would love, so Robin, that was your question. Put it into the comments. Let me know. I'll let you judge on that. Were you able to stump, or did we get the right answer for you? I'd love to know and hear about it. That's for sure. Oh man. They say, darn, y'all win. So I was totally ready to write the service center right here on the stump, but sorry guys, well, better luck next time. We'll try it out. All right, we do have another question coming in about how many dog breeds are there in the world? I don't know. I love my dog. And I guess,
I think there's over 300.
300.
And what's really interesting, up to roughly the 1800s, there was only about 30 different dog breeds. And then in the 1800s, especially during the Victorian era, they decided to breed these different varieties of dogs, and that's where we're ending up with like over 300 dog breeds. So I'm going to say around 300, but about 150 years ago, there was only about 30-ish different dog breeds. So it's really because of humans that we ended up with dog breeds. So humans were looking for dogs that had certain attributes, and then would breed those dogs to have those attributes continue on. And that's where we end up with all these dog breeds. So small dogs, big dogs, and things like that. The funny part, they're all dogs. They're all actually all the same species, just slight little variations from each dog. Now, that being said, I don't think a Chihuahua can really mate with a, let's say, a big Saint Bernard. It's a little bit hard to do that. But, no, and then we're seeing these dog breeds meeting together, and then we get these mutts, and we're seeing more of these different breeds that were separated and now coming together, like a Labradoodle and things like that. So I will say about 300.
300.
I want to just add something to Bruce's answer, because I see like one or two people putting responses in the comments saying that the number is fewer. And the reason why the number might seem to be fewer if you search around is because there are associations that recognize certain dog breeds as official. So there are a lot more breeds of dogs that exist in the world than what are officially recognized. And when we talk about official dog breeds, we're talking about like pedigree breeders who tend to use their dogs in like competition or for very selective breeding purposes. So there are quote unquote official breeds, and then there are other breeds that exist in the world that are not officially recognized by these overseen kind of governing bodies, I guess you can call them.
So something like the Canadian Kennel Club or the American Kennel Club or the British Kennel Club or something like that, right?
Exactly, and that's a great point. And they also recognize different breeds. Some of them have started to recognize the Labradoodle, for example, which up until a few years ago, no one had ever heard of a Labradoodle. That was just another different kind of mutt. And now everybody wants them, right? So that's what's winning the Kennel Club shows.
So I think on this one, we can almost say that maybe there isn't quite an answer. It's kind of malleable, right? Like it could be as low as, like some people are suggesting 160, or as high as, like I said, I did a quick Google as the host because I was curious, like 220, I've seen 260. So it's kind of, I think there's all kinds of different numbers out there. So I don't know if you stumped us on this one, but I think there is, it's one of those things where we just don't really know the answer to that one in particular. But I think it makes a good point that all dogs are dogs and they're all the same species, right? Just like I have a different color of hair than many of you might. So that's absolutely good. Oh, Amanda, I don't know. Amanda, kind of a question came in. This is a great one up for debate. Which came first, the chicken or the egg?
Egg.
Egg. Dinosaurs were laying eggs long before the first chicken came clucking around.
I love it.
Very good. Oh, that was a good one, but I don't think you stumped the scientists on that one. Which came first? I had to pull that one. Oh, that was a really good. Oh, Megan, I know you're gonna love this question because this is one of my favorite animals on the planet. I know you love them too. What is a tardigrade?
I love tardigrades. Yeah, for sure. So tardigrades are a tiny microscopic animal. They're in a group, a species all on their own. They are very cool little tiny animals, and they're called extremophiles because they love the most extreme environments on our planet, but also in space, which is awesome. They're the only animal that has survived the vacuum of space. And they're super cool because they can actually dry completely out, encyst themselves, and survive for years and years and years. And all you have to do is add water and poof, they come back to life. And they're found everywhere. Everywhere. You could find them at home if you wanted to, especially now where the sun is out and spring is springing. And if you go and get a little bit of moss from outside and kind of soak it in some water for a little while, and if you have a microscope at home, you can look for some tardigrades in that moss. I've never successfully done it, but you can try.
I love them because when you look at them under the microscope, they look like microscopic bears.
Yes,
they're really cute.
And I see somebody actually wrote water bears, and another common name for them is water bears. Absolutely.
And just correct me if I'm wrong. They have 6 legs, don't they?
They do.
I mean, that is if you don't know what a tardigrade is, go and Google that because they are really, really neat creatures. I love that one. All right, here's a question coming in from Kalpana. How can people stand on the bottom of the Earth? Also known as Antarctica. How do we stand on the bottom and not just fall off?
I'm laughing. Tyler, you want to start this one?
It's a good question.
Gravity?
It is a great question.
It's a
Very, very skilled people.
They're actually hanging on by their teeth for dear life.
Sticky boots.
Antarctica isn't the bottom of the world. The world is round. It's a sphere. It's a ball, right? I hope we can all agree on that.
Yep.
And if we can't, well, come in sometime and we'll try and convince you. But the ball, the Earth, and we normally, imagine the north is the top, and south is the bottom. But you could equally imagine that south is the bottom, or the top, and north is the bottom. Gravity is pulling us towards the ground, which is in the middle. It's always pulling you towards the center of the Earth, no matter where on the Earth you are. And so Antarctica, the center of the Earth, is still, it's under the ground. And so it's still pulling you down towards your feet, towards the Earth. And so you're not going to ever fall off the world no matter where you go.
Think of the Earth as an apple. The center of it is its core. So that's the center of the Earth, and that's where the gravity is pushing you towards. You have the mantle that's going to be all around it. So that's the fleshy part of your apple that you want to eat. And then you have the crust, which is the skin of your apple. So we live on the crust part of the Earth, on the skin part of your apple, if you look at it that way. And that's still pushing towards the center. So no matter where you are on the Earth, gravity is going to always push you towards its core, its center.
Mm.
Now, keep in mind one thing, being in North America, we tend to think we're on top. But if you actually look at maps of, let's say, people that live in the Southern Hemisphere, they're kind of different than what we see. North America will be on the bottom and South America would be on top. So don't think of Antarctica being on the bottom. It's just at the other end of the Earth of where we are, but there's really not really a top and a bottom. And when you're in space and you're looking at the planet, it's like it could be anything, right? So it's a good question, but there's no such thing as a top or bottom when you have something like Tyler said, or like Jennifer said, that it's round.
And that leads to a question. Sorry, Amy, I seen a question earlier about the North Pole and South Pole, and if we had other poles. Well, in history, in geological history, we can actually see that the poles have reversed. So what we see as a North Pole was actually down in the South Pole at a time, and it flips. And it's a natural phenomenon that happens. It takes millions and millions and millions of years for that to happen. But if we go back in the geology history books, we're actually able to see those changes in the magnetic poles throughout the years, the different years.
Just to make sure everyone understands, we're talking about the magnetic poles that the compass points to, not the poles like of the axis of the world that we're spinning around.
Yeah.
Spinning as a top did not flip. It's all that does not happen.
It's the magnet. The magnet.
It's the magnet.
Yeah, the magnetic part has flipped. Yeah. And it's more. It kind of wobbles around, but when it does the pole reversal thing, it more just kind of fades out and comes back like this, as opposed to whoop around, which is interesting.
Yeah. So that takes a while to happen. Like that couldn't happen tomorrow, right?
No. We're talking like many years, like 300,000 to 500,000 years, like the huge time scale.
Okay. Phew. I don't have to worry about what's happening on Tuesday next week, right? No.
Okay. You're all good.
Excellent. All right, we've got another question coming in from Kimberly. Why do we dream? Ooh. I'm looking at Katrina. Maybe she might have an answer for this.
I'm also looking at Nina because
Nina too. Yeah, absolutely. Why do we dream?
Okay, so I will start. Nina, please jump in. So dreaming is really kind of your brain's way of making sense of sort of what is happening around you. So I guess kind of the way that it happens is you go through your day, you're doing lots of different things, you can run into people, maybe you're scrolling on social media, something good or bad might happen to you, and your brain takes all of that information and pieces it together in a really strange and fun way, and that is kind of what your dream is. So this is why you also have nightmares, or why you can have really fun and exciting dreams, or dream things that you just don't understand. So those neural connections in your brain are really just trying to kind of make sense of that information and put it together for you, and remember things that happen. Nina, do you want to talk about some neuroscience stuff?
Well, it's interesting because there are a lot of parts of the brain that are kind of implicated in the sleep and dreaming process. And a lot of them, like Katrina mentioned, have to do with memory. So there are a lot of parts of the brain that are associated with that. One of my favorite things I remember learning about neuroscience and sleep is that there's a part of your brain called the locus coeruleus, which is involved in a lot of like the hormones that are kind of circulating through your brain and body while through your day-to-day, but also while you're dreaming. But it also has a role in helping to control your body so you don't act out your dreams, which is just like a cool thing I wanted to add in, so that it's not a why we're dreaming, but it's just a cool thing that I think is neat. So there's actually a lot of brain stuff going on, but most of it has to do with memory and consolidating our memories and experiences and sort of turning them into long-term storage in the brain.
Yeah. Amy, you're muted.
Sorry. There's some other questions there about do other animals dream? So we had a question, do squirrels dream? Do you think our flying squirrels dream? Do dogs dream? I don't know.
I mean, sometimes my cat does weird things when he's sleeping and you're like, what you doing?
I'm pretty sure dogs dream. I know this is outside my realm of experience, but one, as a dog owner, having witnessed the dogs woofing and pawing, but two, I actually looked it up because I was interested, and they have done studies which suggest that yes, that woofing and paw running in dog sleep is equivalent to the dream state in human beings. So there you go.
Yeah, I was gonna say that as well. Like, Nina mentioned kind of learning some of this stuff in school. When we did talk about dreams, that was something that we looked at, and something that we were talking about. The research that was happening at the time was trying to figure out if humans were the only animals that do dream. So I have a similar experience, because when I was a kid, my dog also used to do that kind of pawing in the middle of the night, like she was running. So there's something going on there. And Nina might have a little bit more to say. She's a little, no, okay. I was like, she's a little bit more of a brain person than I am. But when you're kind of looking at the brain as a whole, like, animals are really similar in a lot of ways, and a lot of that does have to do with brain structure. So if humans can dream, there's no reason for us to think that other animals cannot. We may not experience it or know it because it's very hard to get that kind of concrete information, but that doesn't mean that it's not happening. So I personally think that they can, because I've seen some of these fun things happen with my pets, but I don't personally have concrete information on that. So
You nailed it.
So Annie did ask us, do squirrels dream? I don't know. I don't know if I've ever recalled our squirrels at Science North, doing what dogs do. Like, with that little, I've never seen squirrels do that.
No, they just kind of sleep up in a ball together. So, who knows what they're doing in there?
We're gonna have to. I'm almost tempted to see if Annie, who sent us that question, could win this trophy. I'm gonna sick Renata on that. Renata is one of our scientists behind the scenes. She's gonna Google that. If there's an answer, Annie, you may have just as well stumped one of our scientists, because I don't know the answer to that. So we'll get Renata doing some Googling behind the scenes and see if you stumped us or not, because I think those are really, really great questions. We have one question that's coming in. Which animal is the smartest?
It also depends on how you define smart.
Yeah, that is a debatable answer for sure.
There's no debate. It's me.
Tyler's not that wrong, actually.
What have we got?
Oh, can I add a little something about that?
Yeah.
Okay. So a lot of biologists believe that the size of a certain part of your brain, I don't have my brain model, I had it here, that is called the cerebral cortex. The size of the cerebral cortex will tell you how smart that animal is. So if we think about this, some of the biggest animals in the world, such as whales, have the biggest cerebral cortexes that are out there.
Yeah.
So are whales smarter than humans? We don't know about that, right? That's a very good question.
I want to just add to Bruce's answer there. Another thing that we tend to talk about when we're talking about the cerebral cortex in different species is how many, they're called gyri and sulci, so how many folds there are in the cerebral cortex. Because if you think about brain mass as a piece of paper, the cerebral cortex has a bunch of folds in it, it's crumpled like this, and when it's the more little folds, the more kind of brain mass and brain matter that we can kind of cram into a skull. And there's an association between how folded up that cerebral cortex is and certain higher cognitive functions. So thinking skills and especially social learning. And the animal with the highest number of folds in its brain, so the highest kind of mass concentration of brain going on is not the human. It's the dolphin. It's a dolphin. What? If you look up a dolphin brain, they're groovy.
Literally and figuratively.
I was going to add too that there are so many social animals out there like dolphins and other great apes and elephants, and they're very social, and they build these really complex connections with each other. And if you were to use that as a measure of intelligence and how some animals will make and create tools, like it's a very complicated question. Absolutely.
Yeah, absolutely.
I think the only thing I would add to all this is when you look at all these animals that have all these brains, whether it be the dolphin and other ones with that, and you look at their bodies and body structure, things like that, they're much better equipped than humans. We're kind of weak and no hair and nothing. So we've really had to use this in order to survive. So I would almost have to say, we'd have to almost give a kind of thumbs up to humans, because knowing what we are physically and to still be around, it's because of this, a lot more because of this than a dolphin that can like be streamlined and grab fish and things like that. And they have hunting techniques that are just amazing, things like that. But humans, if we didn't have a brain that actually worked, we would have been eaten a long time ago.
So it boils down to, it depends on how you're defining smart.
I guess, yeah.
And how you want to quantify it / qualify it.
Interesting. Yeah, absolutely. I think those are pretty good answers. I see, and I didn't even really know that about dolphins, so that's pretty neat.
Yeah, as opposed to like, I love my cat, but a cat's brain is very, very smooth.
That's
a rat's brain is even smoother. Rats' brains are like super, super like frictionless.
Have you pet a rat's brain?
I have held a rat's brain in my hand.
But did you pet it?
You know what? It's been a long time. I wouldn't put it past myself. Like, I wore gloves. I can say I wore gloves.
Oh, that's a good one. All right, Parker has a question for us. I'm hoping this one might stump our panel a little bit. So I'm trying to find ones that, might stump us a bit. How was the first glue made?
Like horse glue?
I don't know. Something that's sticky.
I think
mud?
you're right, Nina. In the historical record, I think it's hide glue from horses.
Yeah. Because like if we talk about like adhesive properties, we'd probably be going back to like some forms of mud or clay to help bind things together. But in terms of like proper glue, I think, I'd agree with Tyler that it would be like a hide-based glue, perhaps.
Yeah, not horse though, because unless you count wild horses, because I remember reading about Neolithic finds where they've got stone stuff glued together, stone, like the bone, there's a piece of bone or wood, and then the stone tools wedged in there, and then there's some sinew soaked in boiled hide to glue it, and it makes a real solid joint, right? And that goes back tens of thousands of years. So we would call that hide glue, and it's really hard to get nowadays, but that would be
that's what they would have boiled hides of animals, right?
Yeah.
So that's probably one of the besides mud. I mean, I would agree with that, right? That's probably animal hide would have been the very first type of glue probably made. That was
maybe tars, if they came across tars, like there's certain parts of our world where you got these tar pits, you could have probably used that as a glue also.
Jennifer, are there any tar pits in East Africa? Because like that's where humanity got started, according to the fossil record. So if there aren't tar pits right there, we'd have to go a ways before we would have found them in our exploration of the world.
You know what? I got stumped on that one. I don't know if there's any tar pits in that area.
Yeah, I get my name on the stump.
Do I need to write Tyler's name on the stump? I don't think that's quite fair, but that's all right. That says lab space at Science North. It might look a little funny if your name was on the stump. That would be.
I would have originally said mud would have been the first type of adhesive glue. Mud, and that dates back very far back. Even everything you were making from little type of shelters, mud was like the basis of everything and holding it together, and then it would have evolved from there.
and it would have evolved from there. That's pretty cool. That's pretty cool. All right, we've got time for one more question. I'm trying to find one that I think might stump us. We've talked about smart animals. Oh, goodness gracious. I'm going through the list here. Ooh, boy. I know there was some.
Robin's service had one about farm implements, and I can tell you right now.
Oh, yes. Do you want to answer that one? That's from Trenton.
No, we're stumped.
We're stumped? Did Trenton stump us on that?
Did we lose Trent?
Most, but
I think Mimi got
on that one. So no, can anybody answer the Trenton one?
What's the question?
It was what farm implement tears up the field every 3 years? And that would of course depend on what your farming methodology is, where you're doing it. That's a huge variability. But
third harvest tears up the field every third harvest.
Like a subsurface plow, if you're on clay, you might want to do that. But again, are you on clay? Are you on sand? Are you no-till? What the heck is going on here? It's a very hard question.
Is the question about the actual?
It's the name of the implement.
The tool itself, yeah. I think we got stumped on that one.
We got Amy back.
Yeah, sorry, my internet just went.
Welcome back, Amy.
Yeah, so we're so stumped. It blew you away.
It did. It just did. That's absolutely right. It knocked everything out of my house here. It just knocked everything down. Are we stumped by that one from Trenton?
We are stumped.
Oh my gosh. All right. So in my notes, Trenton, that is a really great question. Thank you so much for asking us. We will engrave your name on the Stump Trophy. It will be at Science North. Please come visit us from Brockville. We would love to. Absolutely.
Oh, sorry, it wasn't Trenton. Just checking the comments to make sure we have the right name. This was Robin's service.
Oh, yes. Robin and Trenton go together.
Not Trenton, but Robin.
Yeah. That's good. So, we'll put both of your names on there. That would be great. I do have one last one that I saw. What can only be destroyed by throwing it into a black hole? Is there one thing in our universe that, it can only be destroyed if we threw it into a black hole?
A tardigrade.
Maybe not. Indestructible, those tardigrades.
What's the question? What can or cannot?
It could only be destroyed by throwing it into a black hole.
Is time? I don't know.
That's actually a pretty decent answer.
You know what? I'm going to go with tardigrade. I think that is definitely the answer of the day. Don't Google that. That's,
What can only be destroyed?
And I don't know if there's an actual answer for that or not.
Yeah, no, I don't. I'm not coming up with anything that is remarkably. There are many substances where it would be hard to think of how you could destroy them. Like if you had a solid block of iron, kilometers across in space, well, I want to destroy that into the black hole. That's an easy answer. You could probably throw it into a star too, toss it into the sun, and it would go away. If you had something like a chunk of a neutron star, you wanted to get rid of your neutron star, I can't think of another way to destroy that than a black hole. But if I rammed another neutron star into it and they all went to smithereens, well, it's gone. So that would count as destroyed, right?
Yeah.
I mean, if you had godly cosmic powers to throw things into black holes, you could throw things into other things, right? So
Tyler, an answer that's coming in, I believe, from the question poser is saying strange matter. Did you want to elaborate on strange matter?
Oh, strange matter, yeah.
So I'm like, that seems in your wheelhouse.
Yeah, okay, so that sounds more like we're coming out of sci-fi, unfortunately. Strange matter in my learnings, there's this thing called strange quarks, all right? And so, which are, like, quarks make up, are like the next level down building block from matter underneath protons and neutrons. You've got atoms, and then the atoms have electrons, protons, and neutrons. The protons and neutrons have different kinds of quarks inside them to decide whether they're going to be protons and neutrons. And protons and neutrons are the ordinary kind. Those have regular old up and down But there's other flavors of quarks. We call them flavors. Charmed and strange being, and top and bottom. Fun names, right? And, so there's a form of degenerate matter called strange matter, where basically what you got is you take your regular old matter and you squish it so hard that it stops being able to hold together. You squish your protons and your neutrons together, and and your electrons, you make a soup of neutrons, and that's a neutron star. You push that even harder, and the quarks start to fuse together, and you get top and bottom quarks squishing into strange quarks, and you get this strange matter. But if you release the pressure, it's not stable. It goes boom. You need a lot of gravity. We're not even sure if it can exist. If it does exist, it's destructible in the same way that a neutron star would be. You just chip pieces off and it's gone. It fizzles, evaporates. But otherwise, a good way to get rid of a lot of it would certainly be to throw it into a black hole. So I suppose we could put that name on the stump too. They're not wrong. That's something that you could get rid of in a black hole. Good on them for knowing about strange matter, for sure.
Yeah, that's a very, very cool thing. And I can't, I've gotten so many different things. I can't find where that is, where that name got put to on my list. So many things, but we will find it after, and we will definitely think. And Annie, I was just about to get to you. Did we win, Renata? Were you able to find whether or not squirrels can dream?
So Renata searched Google Scholar, and she could not find a paper about it. So there's no answer. We're not stumped, I guess.
We're not stumped, sorry, Annie. There's just no answer because we just don't know. But you know what? Maybe that means that a scientist out there who's got a passion for dreams and squirrels could figure that question out one of these days. That's really great. Well, you know what, guys? This is the end of our hour today. I just want to tell you that, this has been so much fun. Thank you to all my crew from Science North. We definitely got stumped twice today. Oh, thanks, Tara. That's from Nathaniel and by Trenton. So thank you so much. Your names are going on the Stump Trophy. Woo! So next time you visit Science North when we reopen, you can come. You'll have your name engraved right on here, and we will love to just tell us who you are when you head up into the Science Center, and we'd love to see you and meet you there. So thank you so much for joining us, everybody. We have a great, still 2 or 3 more days of amazing science that is online with us here at Science North. You can head to the Science North Facebook page. There's lots of information about what is heading up for the rest of the week, and I'm sure we'll see you back here later in the week for some continued amazing science content for this spring break. So thanks for joining us from home, everyone.